Hello everyone, welcome to the second recitation on the AWS. In this recitation, we're going to talk about EC2 instances, what are AMIs, what are the different instance types offered by AWS. We're going to talk about security groups and how to configure them. Then we'll talk about SSHing from your local machine onto the AWS server, and then finally wrap up with talking about an elastic IP. All right, let's get started. So when you log in to your AWS, you're greeted by this screen over here. And so since we work with EC2, we search for EC2 and we go onto their landing page. Over here, you see this launch instance button in orange. We click on that. We click on launch instance. That takes us to the configuration page for this instance. So let's name our instance. We just call it Recitation. All right. Now we have to select an AMI. Now, what exactly is an AMI? An AMI stands for an Amazon machine image, and that basically is an OS which is running on the instance. So you basically have these pre-configured OS images which are put on these instances. So you don't need to worry about a lot of the boilerplate stuff which happens underneath. So we recommend two primary AMIs for our use case for deep learning. The first is the deep learning AMI on Ubuntu 18, and the second is the deep learning base AMI on Ubuntu 18. Now, both of these AMIs come with the NVIDIA drivers, CUDA and CUDN installed. The main difference between the both of them is that in the deep learning AMI, there are pre-installed packages, so you need to worry about a lot of the installation and the setup required to do your experimentation. Now, since there is a package which is already installed, the base occupied boot volume is higher in the deep learning AMI, but they also compensate for it by giving you a higher boot volume size overall. Similarly, in the base AMI, as you would expect, the OS itself occupies a smaller boot volume, but the boot volume size is accordingly reduced a bit. All right, since we know what we're looking for, we can now search for deep learning 67. And as soon as we hit enter, we are taken to this catalog. We click on community APIs and select Ubuntu. Scroll down, and this is the API AMI that we're looking for, the deep learning AMI. There is a deep learning base AMI as well. We don't want to work on setting up the package itself. We're going to be using the deep learning AMI, so we select it. And we are now back onto this configuration page. Now let's talk about the instance types. So in the previous recitation, we spoke about how we're going to be using the P-type and the G-type instances because they have GPUs. Now within these GPUs, there are multiple of these different GPUs which are offered by NVIDIA itself. So the P4 has the A100 GPUs, which are very powerful GPUs, which we would not recommend for most cases, but of course, as your use case might be, you might want to use the P4 instance for your experimentation. We primarily would be working with NVIDIA T4 GPUs, that is the EC2 G4 instance. And now within all of these instances, there are sub-instances which exist. To name a few, these instances are shown on the screen. The T2 micro is usually not very useful for most of our use cases. We would primarily be looking at the C5 X large because that can be used to develop your code and we do not recommend it for running your experimentation or your training because it doesn't have a GPU on it. The G4DN extra large is what I've been using for the most part for experimentation. And the P3 2X large has a even more powerful GPU, but it is also very expensive, comparatively expensive. All right, so we're going to be using the G4DN instance primarily over here. One other website which can help you to navigate what instance type works best for you is to visit instances.vantage.sh. That gives you a list of all of these GPUs that are available and are offered by AWS itself. So since we're using the G4DN extra large, we're going to select that. And we're going to go on to working with the key pair login. A key pair login, think of it like a password to the AWS server. So what we're going to do is we're going to create a new key pair. Over here, we're going to call it 11785 AWS key. And we select, okay. We're gonna select RSA and we're gonna select a PEM file. What this does is it creates a login. It gives you a file, a PEM file, which you use to log into your server when you're SSHing into it. We'll talk more about that shortly. Next, we go on to network settings. Over here, we're basically configuring the firewall of your server. So there's an additional layer of security that we are adding to your configuration. So we usually name our security group. So let's just call it ideal security. And as you can see over here, it has already been configured for SSH on port 22, which is the default port for SSH. And the source type is set to anywhere, which means that you as a user can SSH into the server from anywhere. You don't need to worry about configuring your IP. So as you would be working on campus, you would be working at home or like a different location itself, your IP would keep changing. And so you have an option to configure your IP address from which you would be connecting to the server. But since that is not sure, we strongly recommend to use anywhere as your source type. Next, we will add a security group for your Jupyter notebook. And so a Jupyter notebook opens up a port at 8888. So we're going to use that. Second. All right, you're going to use that and you're going to change the source type to anywhere, like I said before. All right. Next, we go on to the storage. We are provided with a 140 GB hard disk with this instance, so we don't need to worry much about it because this is more than enough for what we're trying to do here. Next, we go on to advanced details. All right. So in the previous recording, I spoke to you about how there are spot instances and you have on-demand instances. Now, within spot instances, there are two types of sub spot instances. One is a persistent spot instance. One is a one-time spot instance. So let's talk about all three of them. So the on-demand instance is basically when you give Amazon some money and Amazon guarantees that you get a computer to work on, an instance to work on. When you go on to spot instances, these are instances which are provided to you depending on what is the load on the AWS server, the region on which you're working. For us, that's Ohio. So if there is an increased load on the AWS server, the likelihood of getting a spot instance would reduce. And vice versa, if the load is lower on the server, your likelihood of getting a spot instance would increase. Again, the prices over here fluctuate depending on how much is the load. And so you can always adjust your price to ensure that you get a spot instance. The main difference between a persistent spot instance and a one-time spot instance is that when AWS comes to interrupt your instance, let's say you have let's say AWS is decided that it cannot offer you a spot instance anymore and has to interrupt your instance. In persistent spot instances, your instance is stopped or hibernated, whereas it is terminated in one-time spot instances. Now, what does stopped and terminate mean? So stopping an instance is equivalent to shutting down your computer, putting it away, and working on it later on. But when you terminate your AWS, you shut down your computer and you throw it into the ocean and you never find it again. That's what terminate is. You don't really get back the data. It's lost forever. So this is important that you understand the difference between stopping an instance and terminating an instance. All right. So now how do we make that happen over here? So you can request a spot instance over here and you can customize your spot instance. Now, requesting type, you can change your instance to one type or persistent, and you can set your maximum price. Now, how do you decide what is the going cost? So again, you go back to this website over here, instance.vantage.sh. That gives you a rate chart or what is the current rate going for that particular instance. So for our case, it is at $0.52 an hour. So you can add an extra cent to it to ensure that you always get an instance and run a spot instance. But we are not worried about that right now. We would use an on-demand instance. So we click on launch instance. Now, while that is happening, in the background, AWS is setting up a machine assigned to you with the particular AMI, which is the deep learning AMI. And you can see this under your instances tab under instances. So as you can see, this is being initialized currently. And now you'll see me once it has been initialized completely. All right, so now our system has been set up completely. It has passed the checks. And now we move on to connecting with it. So once we click on it, we see all the configurations that we've used to set it up. This is the AMI that we're using. And now we click on connect on the top right and click on SSH client. Now we're going to be SSHing into our system from our local machine. Now in the beginning, when we're setting up a key pair, we downloaded a PEM file. So let's now talk more about that. So we go on to download and we see our PEM file. All right. Now we need to move this PEM file into our SSH folder. Depending on what OS you're running, you would have different locations where you would store these files. So in Windows, it would be stored under C users, your username.ssh folder. In Macs and Linux systems, it would be stored in your root, which is users.user/user/usernames for Mac, or just tilde for Linux, .ssh. Since I'm using Ubuntu, this is where I'll be moving my file to. So I'm going to move 11785 pm to .ssh, and now change to .ssh. Now I need to make sure that nobody can change this write to this file or change whatever the contents of this file are. So I change the write permissions, which I do using chmod 400. All right, so now our PEM file is ready. Now we talk about connecting to the AWS server. So we come back to the console and we see this command over here. We click on this icon. This is the SSH command which we'll be using to connect to our server. So as you can see, I enter yes to add it to my list of known hosts. And we have now established a connection with the AWS server. All right. As you can see, this is an EC2 instance with our selected AMI. And this comes with a bunch of different packages, like I said before. We're going to be working primarily with PyTorch. So there's an environment which deals with PyTorch specifically. And so we're going to use this virtual environment, which has this setup done for us. So we're going to use this and we source that environment. And then we want to check if this environment has all PyTorch just to verify it. Of course it does. So we just do import torch. It usually takes some time the first time around when you're trying to import torch. Let's try it again. All right, so we try that again. We do Python 3 and we do import torch. And we have successfully imported torch on our server, which is on AWS. Congratulations, you can now run your experiments on AWS server. All right, now let's talk about an elastic IP. So you see over here, you've got this very weird string of information which is which is associated with your SSH command. So what you can do over here is basically get an elastic IP, which is basically an IP which is assigned to your account. And once that IP is assigned to your account, you can interface it with an instance which is already running. So you SSH into that instance using that IP, and that is connected to your instance. So how do we do that? Let's talk about it. So we go into network and security tab and click on elastic IPs. We click on allocate elastic IP address. We select our zone and say allocate. All right, so now this is an IP which is addressed to our AWS account. So now we need to associate this IP address with our instance. So we say actions associate elastic IP address. Now we have to select an instance. So as you can see, we named our instance 11.85 recitation, and we're going to be using that. We don't really need to worry about selecting a private IP address, you can select a reassociation wherein you keep that IP, you can keep changing your instances as you have multiple instances running. If you do that and you click on associate, and voila, you have now associated an elastic IP to your instance. Now, how do we use this IP after all? So let's go back to our terminal. Let's now log out of our VM. And then right from there. All right, change into my SSH. And now, as you can see, this was the original command that I used to SSH into my instance. Instead of this, I'll just add the IP address. So it'll be Ubuntu at the IP address that is assigned to you. You add it to your list of known hosts. And you have now been able to log into your AWS server using your elastic IP. Congratulations. Now, let's say you've worked on everything, your work is now complete, and now you want to stop or terminate your instance. How do you do that? Please note the difference between stopping and terminating an instance. As I explained to you before, this can be a lot of hard work lost if not done properly. All right. So let's say we want to now terminate our instance because we are not working on it anymore. So we click on the instance which is running. We click on instance state and we say terminate instance. It asks us if you want to terminate it. We say yes. And with that, it shuts down your instance completely. One important thing to remember about elastic IPs is that you will be charged a fixed amount of money if it is not associated with an instance for getting you that IP. So if in case you want to shut down this IP, you would have to first release the IP, and then you would first have to dissociate your elastic IP with your instance, which is basically saying that okay, this IP is not associated with this instance anymore. And then once that is gone, you say I don't want this IP either. So you click on release elastic IP address. All right, that concludes our second recitation, and now I will leave you in the hands of Rooming for explaining how to attach storage to it and interfacing our Google Colab with an AWS server. Thank you.